Oh, no, here we go. Greetings and welcome, friends. We've been taking a look at basic trig identities. Don't let the word basic discourage you if you find yourself in this video not knowing how to do some of these problems, because these still get a little bit tricky. We're on about page 427, and here's problem 23, and it said, prove that this is not an identity. What's up, 23? Did I say this wrong? That's fine. That's good. So here's problem 23, and we're trying to prove that this is not, all right, not an identity, all right? And we're going to do so by providing a single counterexample. You guys can see that the book provided 45 degrees, right, as their counterexample, but that's not necessarily the only one. So what's a value that you guys would like me to try? Was 30 degrees or something, or you want me to just go straight up with the 45? Sure. Fine. You guys aren't very interesting. So is tan squared of 45 degrees plus cotan squared of 45 degrees, is that equal to 1? Is the claim. We're hoping to prove this wrong. And even if it worked, that doesn't mean I proved it is an identity. It just means that maybe you should try another counterexample. So remember that tan squared 45 just means the square of tan of 45, right? So I want to figure out tan of 45. What is tan of 45? I believe that's 1, if I'm not mistaken, right? Yes. Cotan squared is the same as 1 over tan squared of 45, right? If you want to use the reciprocal identity to try to figure that out, because I don't have a hand trick for the cotangent one. I suppose you could just do the square of the fingers to the right over the square of the fingers to the left, but let's pretend we didn't know that. So this is 1 squared plus, what is tan of 45? 1. So 1 squared equals 1. Eventually I'm just going to get 1 plus 1 equals 1, which hopefully we recognize is not true. So 45 degrees is a counterexample, all right, to this being an identity. And also I just want to point out, I believe at 90 degrees, tangent is undefined. So I could have plugged in that and I would have gotten like an undefined equals a 1, and that also would have just broken the world of math and it would have all been sucked into some sort of black hole. So that could have worked as well. So let's see. Now here is the reason we showed up to this fight. It says, use the given information to determine the exact trigonometric value. So it says, if cosecant theta is the square root of 11 thirds, find the value of cotan theta. But then they also specified that they wanted theta to be between those numbers. Okay. Aha. So if I'm between the values of pi over 2 and pi, what quadrant am I talking about? Well, here's from 0 to pi over 2, here's from pi over 2 to pi, here's from pi to 3 pi over 2, and then 3 pi over 2 to 2 pi. So I'm talking about quadrant 2. So that might affect the sign that I'm working with. And I guess in terms of sine and cosine, here cosine positive, sine positive. Here cosine negative, sine positive, right? For the ordered pair sort of thing. Here's negative, negative, and then here cosine is positive, sine is negative. What? I don't know. Anyways, so it's saying if cosecant theta is the square root of 11 thirds, which now, wait a minute. Okay, we're going from cosecant to cotangent. Do I have a trig identity that can link me between those two? Yes. I have one of the Pythag identities, right? Pythag. And this one specifically says that 1 plus cotan squared theta is equal to cosecant squared theta. All right? So that's going to be my bridge between these two trig ratios. So if cosecant theta is the square root of 11 thirds, that means I'm going to be able to plug that in right here. All right, so I will have 1 plus cotan squared theta is equal to the square root of 11 thirds all squared. So 1 plus cotan squared theta is equal to, well, if I can square distribute an exponent over division, right? So that's 11/9. And then we'll subtract 1 from both sides, which subtracting 1 is the same as 9/9, I believe, right? So that's going to be what, 2/9 equals, yeah, 2/9, because 11 minus 9 is 2. And what do I do now to solve? Root both sides, which algebraically, once I root, I technically have 2 answers here. So I would have cotan theta is equal to plus or minus the square root of 2 over, and what's the square root of 9? 3. So I don't have a radical in the denominator. Now, cotan theta is not going to equal both of those if I'm restricting it to this quadrant. It's only going to be positive or negative, and I got to figure out which one that might be. Now, right, well, let's see. I know that tangent theta would equal the ratio of these guys, right? So that'd be positive over negative, which is negative, right? Tangent is the ratio of sine to cosine, or y over x, and in that quadrant, tangent is negative. Now, if I reciprocate a negative number, does it change its sign? No. So anywhere tangent is negative, cotangent is negative. Similarly, anywhere sine is negative, cosecant is negative. Its reciprocal will be negative. And anywhere cosine is negative, then secant will be negative. So I expect that I'm actually only interested in the negative version here. So cotan theta is equal to negative root 2 over 3 if I'm talking about values of theta that are in that restricted domain.
How come there's a 3 in the denominator?
Because the square root of 9 became the 3. And the square root of 2, I didn't know how to simplify any further without making it worse. Okay, so this was 1 degree of separation. I saw cosecant, I saw cotangent, and I looked through my trig identities and I was like, aha! I found one that links them. Let's look at one that has 2 degrees of separation. All right, so I'm going from secant to sine, I hope. All right. Now, let's think about this. From secant, I can get, what can I get? I can get cosine, right? From secant, I can get cosine using a reciprocal identity. Right? I know that cosine theta is equal to 1 over secant theta. All right? Once I get cosine, could I find sine?
Yes.
What identity does that? Pythag. Right? So Pythag, specifically the main one, sine squared theta plus cos squared theta equals 1. So I'm going to get cosine, then plug cosine in here and find sine. All right, so 2 stepping stones. Is this the only way, I wonder? Yeah, the other ways would be more complicated. From secant, I could have gotten tangent. From tangent and sine, I could have gotten no, I don't think that would be helpful. Yeah, so I think this is really might be the only way. So let's see. So cosine theta, therefore, is equal to 1 over negative 7/5. Or cosine theta is just the reciprocal of that, negative 5/7, right? We'll talk about what quadrant we're in a moment. So if that's cosine and I want to find sine, now I can take this and plug it in right there. Right? So that means sine squared theta plus negative 5/7 all squared is equal to 1. So sine squared theta plus, if I square top and bottom here, that's 25/49, and it's positive because squaring a negative becomes positive. Subtract it from both sides. And I'd need a common denominator here, which would be 49. So 49 49ths minus 25 49ths. I believe I get sine squared theta equals, what's that, 24 49ths? Bless you. Ditto. So let's see, now what do I do to get sine theta? Root both sides, plus or minus. I'll never forget it. Never gonna forget. Let's see, sine theta is equal to plus or minus. Square root of 24. I can reduce that to the square root of 4 times the square root of 6. Square root of 49 is 7. So sine of theta is equal to plus or minus 2 square roots of 6 over 7, hood. Now, I've got to figure out, do I want positive or negative? And let's go back up to our initial fact. It said we were talking about which quadrant? 180 to 270's quadrant 3. Is sign positive or negative there? Negative. So I'm interested in just the negative version to this. So sine theta is equal to negative 2 roots of 6 over 7. So the ones that have the 2 stepping stones are a little bit trickier, but just fidget around with them, see how many links you can make to kind of bridge the gap there and eventually get what we're looking for. So thanks for watching, Internet friends. Bye-bye.